أهلا وسهلا بكم بلقاء هذه الليلة، ليلة 25 يونيو حزيران 2024. إن عنوان محاضرتنا لهذه الليلة هو التوأم الرقمي ديجيتال توينز. سيقوم بتقديمها الدكتور مهيار حسون. وهذه نبذة مختصرة عن سيرة الدكتور مهيار الذاتية. ولد الدكتور مهيار في مدينة البصرة، حيث حصل على بكالوريوس في الهندسة الكهربائية من جامعة البصرة في سنة 1976، ومن ثم أكمل دراسته العليا في المملكة المتحدة وحصل على شهادة دكتوراه في هندسة الحاسبات في سنة 1986. حصل على درجة الأستاذية الكاملة في عام 2009، وله أكثر من 33 عاماً من الخبرة كأستاذ أكاديمي في مجالي التعليم الجامعي والبحث العلمي، حيث عمل في جامعات بلدان مختلفة كالمملكة المتحدة والأردن والعراق والإمارات العربية المتحدة والولايات المتحدة الأمريكية وكندا. ولم يقتصر اهتمامه على القطاع التعليمي فحسب، وإنما عمل أيضا في القطاع الصناعي جنبا إلى جنب مع عمله الأكاديمي، حيث كان له دور محوري في مشاريع هندسية مهمة في اسكتلندا والعراق والإمارات العربية المتحدة. وفي فترة معينة من حياته المهنية تفرغ للعمل في مجال تكنولوجيا المعلومات في القطاع الصناعي في كندا، وهو باحث نشط له بحوث كثيرة ومشاركات إدارية وتنظيمية في مجلات ومؤتمرات دولية عديدة حول العالم. وورد اسمه وبحوثه في حوالي 900 ورقة بحثية وفقا لموقع academia.edu. أكتفي بهذا القدر من التقديم، وأحب أن أذكر الحضور أن المحاضرة ستستغرق 45 دقيقة، ستتبعها أسئلة وتعليقات لا تتعدى دقيقتين لكل مشارك. سينتهي اللقاء في تمام الساعة 10:30. نتمنى للدكتور مهيار التوفيق في محاضرته هذه الليلة. والآن أطلب من الحضور وضع الميكروفون على حالة الميوت استماعا طيبا. تفضل دكتور مهيار.
شكرا أبو محمد على التقديم. بس تصحيح صغير، أنا لم أعمل في الولايات المتحدة، يعني هاي الدول اللي ذكرتها ما عدا الولايات المتحدة. هاي من عندك زيادة. تسلم، شكرا. طيب العداد الآن يشتغل من الآن 9:06 الآن 45 دقيقة، زاد الوقت بدل الضائع يعني أيضا تحسب إنه. مساء الخير أخوة الأعزاء في أمسية جديدة من أمسيات الملتقى الثقافي، في محاضرة أسبوعية، ويسرني ويشرفني أن أقدم هذه المحاضرة في هذا اليوم. أقدر أسوي شير الآن بس تأكد.
تفضل.
It's okay؟
إيه تمام.
طيب مثل ما حضراتكم تشوفون هو الموضوع موضوع يعني تكنولوجيا علمي، ولكن راح اتطرق له بشكل هاي ليفل توك يعني ضرورات الاستفاده القصوى من الجميع، طبعا جميع اختصاصات مختلفه. فالغرض الاساسي من المحاضره هو التعريف بهذه التكنولوجيا واستخداماتها في الصناعات الاندستريز المختلفه، ومدى تاثيرها علينا يعني بشكل مباشر او غير مباشر من خلال الوسائل والتولز اللي نستخدمها ايضا بشكل غير مباشر. فايضا مثل ما قال الدكتور رشيد المحاضره السابقه، لضرورات طبيعه الموضوع اللي نتكلم عليه، معظم الكلام راح يكون باللغه الانجليزيه. محتويات هذه المحاضره الكونتنتس will be talking يعني الوقت المتاح لنا بشكل سريع. Definition of digital twins, the characteristics of digital twins, the types of digital twins, digital twins components, technologies enabling digital twins, applications of digital twins across industry، وهذا أهم جزء منها تقريبا. The benefits and challenges of digital twins، وإذا سمح الوقت نتكلم عن future implications and trends. The definition of what is the digital twin. Digital twin is a virtual representation of a physical object or system that exists in a digital realm. في physical وفي digital اللي هو الرقمي وليس الإلكتروني. Replica that represent that digital object. It encompasses both the physical and digital aspects of an entity, allowing for the real-time monitoring, analysis, and optimization. The characteristic of digital twins: real-time is a real-time system. Digital twins continuously update their status and database in real world. طبعا من نتكلم عن real time systems قد يتبادر إلى الذهن إنه there's always update from, or there's always connection from the physical object to the digital يعني counterpart. طبعا هذا إذا كان هذا الوضع راح يكون بالتأكيد waste of time and waste of resources and يشكل طبعا ضغط كبير على الشبكة. نقصد بالريال تايم إنه إذا كان هناك change في الفيزيكال object, that change will be immediately reflected on the digital twin. إذا ما في change طبعا ما في داعي أن نتواصل. Dynamic, they simulate the behavior and interaction of the physical object or system over time. طبعا هنا نحتاج أن يكون عندنا simulator. راح أتكلم عن التكنولوجيز اللي that make this possible. Data-driven digital twins rely on sensor data, IoT devices, and other sources to capture real-world information. هذا راح أتحدث عن هذه الشغلة. Predictive, they use analytics and simulations to predict future behavior and outcomes. أخيراً, interconnected digital twin can be interconnected with other digital twins, with other systems, or applications to enable collaboration and information sharing. Types of digital twins. There are, in fact, 5 types of digital twins. The first one is the product twins, and this represent individual physical product, such as a machinery, equipment, or consumer goods. The process twins, this models and simulates the industrial processes. أول product، ثاني processes, manufacturing workflow or supply chain operations. Is not a product but process. The third one is the part or system twins. والمقصود بالpart or system قد يكون system كامل وقد يكون جزء من system فقط حسب الحاجة. And this simulates complex systems or networks composed of interconnected components, such as smart cities, transportation systems, or energy grids. The fourth one is the person twins. أيضا هنا البيرسون قد يكون a complete person أو قد يكون organs from the person. قد يكون هنا طبعا من نتكلم عن person احنا هنا نقصد أو specifically we talk about the healthcare sector اللي ما يتعلق بالإنسان وصحة الإنسان. فقد يكون الريبليكا للإنسان بشكل كامل أو organs, biological systems, organs, or even patient profile used in healthcare for diagnosis, treatment planning, and monitoring. النوع الأخير اللي هو the plant ونقصد به building, the plant twins, and this models and monitor the performance of buildings, the infrastructure or smart spaces to optimize the energy efficiency, maintenance, and occupant comfort. الديجيتال توينز components مثل ما جاي نشوف بالسلايد الآن في 3 components, main components the hardware component, the middleware component, and the software components. And each component لها functionality خاصة بها ولكن أيضا interconnected. نقدر نطلق عليهم loosely coupled، أي بعبارة أخرى أنه كل يونت شبه مستقل في عمله ولكن أيضا متصل بالآخرين. وأيضا مثل ما نلاحظ بالسلايد نشوف أن هناك direction of arrows in both directions. That means the communications between the different parts of the system is in both direction, bidirectional. الكومبوننتس الهاردوير كومبوننت اللي هي تمثل لنا الفيزيكال فاونديشن اوف ذا ديجيتال توين اللي هي الاوبجكت الاصلي. These include sensors, actuators, devices, and computing infrastructure that capture the process real-world data, enabling the creation of digital replica. احنا بنشوف الهاردوير the sensors هي input, actuators are output devices. وهذا يعني يعطينا انطباع انه الهاردوير او الاوبجكت الفيزيكال اوبجكت في هذه الحاله ليس فقط يرسل الابديت وانما ممكن ايضا يستلم اوامر في تعديل بعض الاشياء، وراح نشوف من خلال بعض الاكزامبل. الميدلوير كومبوننت اللي هي it acts as the bridge between the hardware and software components which facilitate data communication, integration, and management. The middleware ensures that data from the hardware sensors here input من الهاردوير part is collected, processed, and made accessible to software application for the analysis and simulation. The last part اللي هو software component اللي هو the brain of the digital twin. And these components use data from the hardware sensors and middleware to create virtual representations, run simulations, and enable real-time analysis and decision-making. I have to go fast on these because time is short. Okay. So, technologies enabling digital twins. مثل ما نعرف انه ما في اي emerging technology بالوقت الحاضر وياما اكثرها الحقيقه emerging technologies تظهر الان في كل يوم تقريبا شيء جديد، ولكن ما في one technology that can work by its own. اي تكنولوجي مثل Internet of Things, artificial intelligence, cloud and edge computing, cyber security, extended reality, blockchain, digital convergence and others, all of them هو عبارة عن أقدر أنا أسميه كإنترفيس. Underneath it, there are plenty of other technologies that make that technology possible. لما نتحدث عن artificial intelligence لا يمكن أن تشتغل لوحدها كتكنولوجيا منفصلة، وإنما تعتمد على كثير من التكنولوجيا الأخرى واللي that make the operation of the artificial intelligence or any other technology possible. So we'll see some of the technologies that are used to enable the digital twin. We'll just talk about some of these. The first one is the Internet of Things. And the term IoT or Internet of Things refers to collective network of connected devices. Small devices may be more sophisticated devices اللي نسميها smart devices. أيضا ممكن نعتبرها جزء من ال IoT. These devices are communicating between themselves and between themselves and the cloud and create a network of objects or things. So a thing in the context of Internet of Things refers to any entity such as device that forms a network. وهي الديفايسز او الثينجز بالانترنت اوف ثينجز كما اخوان كثير من الاخوان يعرفون بها انه على الاقل اهم صفه من صفاته انه connected. It can establish connection and can sense the surrounding, read, make some processing, and then can communicate and send data or send. And the amount of processing يعتمد طبعا يختلف من one thing to another, from very primitive processing مثلا يقرأ درجة الحرارة يحولها من سلسيوس إلى فahrenheit أو something like that. Very simple processing to much more complicated processing. المهم نشوف من الشارت اللي موجودة على اليمين أنه number of IoT things that are now connected to the IoT. The number of things are exponentially increasing. We expect to have more than 75 billion devices connected to the IoT in next year, 2025. The other technology we use or the digital twins needs to operate is the cloud computing. And the cloud platforms offer scalable computing resources and the storage for hosting digital twins and the processing large volume of data. The cloud is not just storage, it can provide different level of services. It can be a complete infrastructure as a service, or can be a platform as a service, or can be only a software as a service. And today's, there are the three largest cloud computing service providers command more than 66% of the global market, اللي هي Amazon, Microsoft, and Google. ومثل ما نشوف بالسلايد, there are of course other providers like IBM, like Oracle, Alibaba Cloud, and others. But these three are the dominating companies in the cloud computing. The other technology is the big data analytics. And the big data analytics is analytical techniques and tools are used to process and analyze the vast amount of data generated by the digital twins. Big data analytics result in reducing the cost, reducing the time, generate smarter business decisions, and new products and services. الأذر تكنولوجي هي اللي artificial intelligence حكينا بها قبل شوية. هي ال AI هي computer algorithm which exhibits intelligence through decision making. مثل ما نشوف اللي الدوائر الثلاثة اللي متداخلة مع بعضها، الدائرة الخارجية تمثل لنا الارتفيشال انتليجنس، الدائرة اللي داخلها اللي هي الماشين ليرنينج. والماشين ليرنينج هي عبارة عن artificial intelligence algorithm which allows a system to learn from data. والدائرة الداخلية اللي هي deep learning اللي هي نقدر نعتبرها machine learning algorithm that uses deep neural networks to analyze data and provide output accordingly. بنتكلم عن الديب neural نقصد بها multiple layer, more than one layer of algorithms here. Deep learning models can recognize complex patterns in pictures and text and sounds and other data to produce accurate insights and predictions. أيضا السيميليشن هو جزء مهم جدا خاصة في الجزء السوفت وير، لأنه السيميليشن يمثل لنا يعطينا الصورة عن الديجيتال توينز. والconcept of digital twins involves creating virtual replica. وفي هذه الحالة نحتاج simulation. We need to understand the digital twins. In order to understand it, it is essential to grasp some fundamental concept associated with the simulation technology. التكنولوجيا الأخرى ل extended reality. طبعا extended reality is not a technology by itself. It's an umbrella. And everybody knows that we have the virtual reality اللي هي complete software, complete virtual representation of a physical thing. وعندنا الاوجمنتد AR اللي هي مزيج من الفيزيكال or يعني combining the physical والdigital components together. وعندنا الثالث اللي هو المور ادفانسد اللي هو الميكست رياليتي الMR. هذول ثلاثتهم هم يقعون تحت مظلة الاكستندد رياليتي. فالاكستندed reality is not a technology, it's an umbrella. وهذه نحتاجها بصراحه، هذه الاي ار والفي ار بصراحه نحتاجها بالديجيتال توينز، خاصه في مجال الاديوكيشن مثل ما راح نشوف في لاحقا. الان نجي الى الجزء المهم تقريبا، بعد ما تعرفنا بشكل سريع على معنى الديجيتال توين وايضا التكنولوجيز اللي that makes possible. نشوف الابلكيشن في ال different industries, and digital twins have يعني found application across wide range of industries. They're transforming the way business operate, monitor and optimize their processes. راح أتحدث عن some of these technologies حسب ما يسمح الوقت. The first one is the manufacturing and industry 4.0. الآن over 80% of companies who implemented immersive technologies identified improvements in their ability to innovate and collaborate in their production, manufacturing, and operation work phases. This is according to the Forrester Consulting study. Digital twins enable manufacturers to create virtual replicas of their production systems, machines, and products, allowing for real-time monitoring, predictive maintenance, and process optimization. They facilitate simulation-based design, testing, and validation of manufacturing processes, reducing time to market, which is a very important factor, and improving product quality. Industry 4.0 initiative leverage digital twins to enable interconnected and intelligent manufacturing ecosystems, where machines, sensors, and systems communicate and collaborate autonomously. الحقيقة احنا تقريبا نقدر نقول احنا في نهاية Industry 4 and Industry 5 is around the corner. And Industry 5, which is not officially yet, some companies like NVIDIA, Qualcomm, Intel, TSMC, Taiwan, and Samsung Korea are leading the way to Industry 5. One example of digital twins in manufacturing is we talk about Siemens, company that use digital twins. Siemens employs digital twins across its manufacturing operations. Digital twins are used to simulate and optimize the entire production processes from production design to manufacturing and maintenance. Healthcare, which is very, very big sector. In healthcare, digital twins can represent individual patient, organs مثل ما قلنا يكون أجزاء معينة الكبد القلب الكلى إلى آخره, or medical devices, or you can talk about patient profile. This enables personalized treatment planning, predictive diagnosis, and remote monitoring. They facilitate virtual simulations of medical procedures, surgeries, and treatment outcomes, providing insights for medical professionals and improving patient care. Digital twins are used in medical research and drug development model, to model biological system, simulate drug interactions, and accelerate the discovery of new treatments. There are many examples of where the digital twins are used in healthcare sector. One is Philips. Philips has implemented digital twins to predictive maintenance of its MRI machines. Philips used digital twins to monitor the performance and health of its MRI machines in real time by analyzing data from sensors embedded in the machines. And the digital twin can predict where the component is likely to fail. When we talk about digital twin for every single MRI machine that is manufactured by Philips, that means each one in use is continuously sending, it has its own digital twin that is continuously sending all updates, all changes, and the digital twin monitor all the operation of these MRI machines, all of them. Each one has a different digital twin, and they can, of course, see how they work, and any malfunctions, any problems, they can, of course, I also predict where the machine require maintenance. Other example in the health sector is the Mayo Clinic. This is a renowned healthcare provider, everybody knows about it, has leveraged digital twin technology to create patient-specific models for improved diagnostics and treatment. And the Mayo Clinic develops personalized digital twins of patients. Another example is the Boston Children's Hospital, and this collaborates with the General Electric Healthcare to use digital twins for pediatric care. They created digital twins for pediatric patients to simulate and predict the impact of different treatments, enabling personalized care plans. The other application is the smart cities. And digital twins of cities and urban infrastructure help city planners and policymakers visualize and analyze data, predict future trends, and optimize resource allocation. They enable simulation-based planning and decision-making for urban development, a transportation network, energy system, and environmental sustainability initiatives. Smart city initiatives leverage digital twins to improve citizen services, enhance public safety, and create more efficient and sustainable urban environments. There are two examples of these. Singapore, for example, has developed a digital twin for the entire city, complete, to support urban planning, infrastructure management, and sustainability initiatives. This digital twin integrates data from various sources, including traffic systems, weather forecast, and energy consumption. The other example is the Shanghai Tower. This is the second tallest building in the world, of course, after Khalifa Tower. Uses digital twins for facility management. A digital twin of the entire building was created, integrating data from sensors and building systems to monitor and manage everything from energy consumption to maintenance schedule. The other example or technology is the aerospace and defense. And aerospace, digital twins are used in aerospace and defense industries to model and simulate aircraft, spacecraft, and defense systems throughout their life cycle. And نتحدث أيضا عن life cycle means that each twin or virtual twin or digital twin will last for life cycle of the physical twin. That means it's continuously connected, continuously monitored, and also updated. They enable virtual testing, validation, and optimization of designs, systems, and components, reducing the development cost and time to market. Digital twin facilitates predictive maintenance, which is very important, and condition-based monitoring of critical assets, ensuring mission readiness and operational efficiency. There are some examples of the use of digital twins in aerospace and defense. NASA, for example, the Mars rover program used digital twins for mission planning. NASA created digital twins of its Mars rovers to simulate various mission scenarios, test equipment, performance, and plan navigation routes. These digital twins replicate the physical and environmental condition of Mars. NASA also has another digital twin system for their aircraft, a new aircraft called X-59, Quiet Supersonic Transport, the QUESST. involves creating digital twin to simulate the aerodynamics and sonic boom signatures of the aircraft. This allows engineers to optimize the design for reduced noise level. Airbus also has employed digital twins to optimize aircraft manufacturing and maintenance. And digital twins of aircraft components are created to simulate and analyze performance throughout their life cycle. This data is used to predict maintenance needs and improve designs. Also, Boeing aircraft design manufacturing, Boeing also use the digital twins بالرغم من سمعتها السيئة في هذه الأيام من مشاكل كثيرة مع Boeing. They use digital twins to simulate and optimize the design and manufacturing of its aircraft. Digital twins of aircraft components are used to test and validate designs before physical production. The last example is Rolls-Royce engine health management system, which is a digital twin. Rolls-Royce مثل ما جاي نشوف بهذا البوستر الموجود slide is a jet engine. They employ digital twins to monitor the health and performance of aircraft engines in real time. That means any single jet machine produced by Rolls-Royce has its own digital twin. أي engine مركبة على أي طائرة من صناعة Rolls-Royce لها digital twin، والشركة طبعا تراقب monitor all the operations of their engines in real time. السكتر الآخر اللي هو energy and utilities. In energy and utilities sector, digital twins represent power plants, distribution network, and renewable energy assets, enabling real-time monitoring, optimization, and predictive maintenance. They support grid management, demand forecasting, and energy optimization initiatives, improving reliability, efficiency, and sustainability. Digital twins enable asset performance management, outage prediction, and fault detection, helping utilities minimize downtime and optimize asset lifecycle. Examples of the use of digital twins in the energy and utilities sector is the General Electric renewable energy uses digital twins for wind farm management. The General Electric company has developed digital twins for its wind turbines to monitor and analyze their performance in real time. These digital twins help predict maintenance needs, optimizing the energy output and extending the lifespan of the turbines. Siemens also has another system called the Siemens Virtual Power Plant, which is a digital twin system, which is called VPP concept, has been put into practice by Siemens, a world leader in energy technology, using digital twin technology. Solar panels, wind turbines, and energy storage devices are just a few examples of the distributed energy resources that the VPP integrates into a unified virtual platform. Siemens builds a virtual reproduction of the full power plant infrastructure, including the physical assets, control systems, using the digital twin technology. Another example is Shell company uses digital twins for its oil and gas production facilities. Shell creates digital twins for its oil rigs and refineries to monitor operations, predict equipment failures, and optimize maintenance schedules. British Petroleum also is another example, employs digital twins for asset monitoring in the oil and gas industry. The digital twin simulates the behavior of offshore platform and equipment, aiding in predictive maintenance, reducing downtime, and ensuring the safety and reliability operations. Another sector is the building and construction, and here digital twins of buildings Infrastructure and smart spaces enable real-time monitoring, management, and optimizing of energy usage, occupancy, and maintenance. They facilitate predictive maintenance, energy efficiency, optimization, and space utilization planning, improving operational efficiency and occupant comfort. An example of that is the Shard in London is a building, one of the tallest buildings in Europe, employs digital twins for facility management. The digital twin allows for real-time monitoring of the buildings, the building systems, including the heating, ventilation, and air conditioning, the HVAC system, optimizing energy usage and maintenance. The other sector, which is a very important sector, is the automotive sector. So in automotive sector, digital twins are used in automotive design, engineering, and manufacturing to simulate and optimize vehicle performance, safety, and reliability. They enable virtual prototyping, testing, and validation of vehicle designs, components, and systems, reducing development costs and time to market. Digital twins support predictive maintenance, remote diagnostics, and over-the-air software updates for connected vehicles, enhancing customer experience and vehicle uptime. Some examples of the use of digital twin in industry and automotive industry is the Ford company utilizes digital twins in the development of new vehicles. The design twin allows engineers to simulate, analyze various aspects of vehicle performance, including safety, fuel efficiency, and overall functionality. This accelerates the design process and improves the quality of the final product. Another example is Sharikat Renault also implemented digital twins of its manufacturing plants to simulate and optimize production workflow. Tesla, on the other hand, utilized digital twins for their electric vehicles. Tesla has a digital twin for every single car they produce. أي سيارة تنتجها تسلا لها digital twin. And they use the digital twins to collect real-time data on vehicle performance, driving patterns, and environmental conditions. طبعا ليست تسلا الوحيدة اللي لها digital twins for all cars. Porsche الألمانية أيضا لها مسوية digital twins for every single car they produce. Other companies يعني سواء German, Japanese, Korean, American, others, they have also digital twins for their cars, but not all their cars. يعني قسم من some of the, for example, high-end models, they have digital twins. واحتمال you use a car, your car maybe has a digital twin and maybe you are not aware of that. Because many companies are using digital twins. As I said, other companies are not generating digital twins or creating digital twins for all their cars, but some of their models. The other sector is education, and digital twins are applied in education for creating simulations and virtual laboratories. And that was very good example when we were in the pandemic time, the corona time. انه طبعا بالمناسبه هذه فتره البانديميك نتج عنها تطور هائل في مجال الفيرتشوال ليرنينج، مو بس بالاديوكيشن، في مجالات اخرى ايضا تم الحاجه مثل ما نقول الحاجه ام الاختراع. طلعت برودكتس كثيره اللي تدعم هذا الشيء. بالeducation, digital twins can be used in various educational settings, from kindergarten to grade 12 classrooms to higher education institutions. For example, digital twins can be used to create virtual science experiments. مثل ما نشوف هذا الصورة اللي قدامنا الآن، يعني أنت تخلي هذا نستخدم في هذه الحالة ال AR وال DR انت كانما جاي تشوف تجربه قدامك تسويها، هي ليست حقيقيه وانما فيرتشوال. وكان ايضا انت ممكن تمزج الفيزيكال والديجيتال components together in one system in augmented reality or even more advanced in mixed reality. في بعض الأحيان هناك بعض يعني الاكسبيرمنتس تكون من نسويها باللاب قد تشكل خطورة يعني بها على الطلبة، فتستخدم الديجيتال توين في هذا المجال. أيضا digital twins can also be used to create virtual field trips and can be used to create virtual replicas of teachers. احنا بعد وقت يمكن معين راح نصير obsolete من تدخل الديجيتال توينز بالeducation. Hopes not so. طبعا هناك تطبيقات كثيرة في مجال education لا مجال لذكرها الآن بسبب الوقت. أيضا سيكتور آخر يستخدم الديجيتال توينز telecommunication sector, which is important sector, and digital twins model network infrastructure, optimize network performance, and support predictive maintenance. There are many other companies that use that digital twin technology, like AT&T, Ericsson. AT&T utilizes digital twins for network optimization, digital twin models, the telecommunication network allowing for real-time monitoring and optimization for network performance. هنا بعض التكنولوجيا الاندستريز الأخرى راح نخصها بشكل سريع أيضا اللي تستخدم الديجيتال توينز. عندنا supply chain management. الديجيتال توينز optimize supply chain management by modeling and simulating the movement of goods, predicting demand and improving logistics efficiently. Example of these, the military transport US Transcom اللي هي شركة مسؤولة عن transport of all military equipment for the United States. They deployed a digital twins solution to replace spreadsheets because of they needed to reduce millions in cost. استخدام الديجيتال توينز بالنسبة لهذه الكومباني ended up in removing 2 billion in cost and saving for this company. Another example is the French supermarket Intermarché. ما أعرف إذا لفظها صحيح ولا لا، كلمة فرنسية. أيضا created digital twin. In retail أيضا application, I will just use the example now. Walmart use digital twins. They include everything from inventory management to transportation logistics. DHL also, they use the digital twins to simulate warehouse layouts and processes. In environmental monitoring أيضا هناك يعني استخدام الديجيتال توينز في ال water resource management والair quality monitoring إلى آخره. في الفاينانس هناك أيضا استخدام للديجيتال توينز. Examples, insurance companies use a smart home integration for custom premiums. Banking, they use virtual financial health advisor. Wealth management, personalized investment strategy designer. أيضا the last one I talk about this the smart agriculture application here. They use it in crop management. Example, the John Deere company employs digital twins for precision agriculture. طبعا هناك اندستري كثيرة لا مجال لذكرها الآن. So move to the benefits and challenges of the digital twins. The benefits. كم وقت أبو محمد باقي؟
بعد 4 دقائق to be exact.
والوقت الضايع؟
يلا 5 دقائق.
اوكي. البنفيتس ايضا راح امشي عليها بسرعه. Optimize performance, benefit enhance efficiency. Improve decision-making, the benefit-informed decision-making, predictive maintenance, minimize downtime, cost saving, the benefit reduce operational cost, the simulation and testing accelerated innovation. Challenges of digital twins, the data security and privacy, the challenge is data vulnerability. Of course, this is always a concern in every single technology. Integration complexity, challenge integration with existing systems. High initial cost, the challenge is the, high initial investment cost. Skill shortage, lack of expertise. Complexity of modeling complex system. Interoperability issues, lack of standardization. Ethical consideration was another important issue, challenge ethical use of data, and this is another concern. Scalability challenges the scalability for large system. How can you, change the size of the system? The future implication and trends. Integration with the emerging technologies, the implication enhanced capability. Artificial intelligence-driven predictive analytics, the trend advanced predictive maintenance, digital twins for complex ecosystems, ecosystem-level modeling, generative design and simulations. The trend is generative design integration, edge computing for real-time processing, the implication low latency processing, reducing the time, digital twin consortia and standards, the trend industry-wide standardization, which is also a concern, human digital twins in healthcare, personalized healthcare, make the healthcare personal for everybody, simulating social and economic system, modeling the social dynamics, autonomous systems and robotics, the implication optimizing autonomous operations, enhance AR and VR experience, the immersive visualization, digital twins for climate modeling, environmental sustainability, quantum computing integration, high performance computing, extended reality for training, and implication is training and simulation, decentralized digital twins, make them decentralized and disputed architectures, and cyber physical society system integration of social dynamics. And that's it, I think, within the time. And thank you.
شكرا.